right, well, next up we have Matthew Fredrickson, which I'm sure a lot of you already know. He's been working at Asterisk a long time, since 2001. Seems like forever ago. And he's recently been jet setting, so I'm sure we've seen him on some fun little adventures. But he's here to talk to us about the Asterisk project and get an update on that. So, everybody, welcome, Matthew.
Thank you, Kathleen. It is a pleasure to be here this year. I was able to come to it last year, and it was a really fun and unique conference. There's a good mix of people and projects and really fun things to learn about. And I was really excited that Dan decided to do it again this year. So I'm grateful for the opportunity to do that. Just first wanted to thank Mira for the awesome talk this morning about diversity and about human bias and things that you do that you don't even know that you do. I think it's important to be self-aware of the things that we do and the reasons why we do them, because it helps us to be better people and improve ourselves as we become more self-aware. So I'm really grateful for that. So as she mentioned, yeah, I'm currently the Asterisk project lead. I've been doing this for about 3 or 4 years, for those who are not familiar with me. I really enjoy working with Asterisk. It's been a passion for me. It's been a love for me for many years of my life. Like Mira, I did not expect to be in the communications industry as well as a young person. I just thought that software development was kind of cool and open source was kind of neat and Linux was pretty awesome. And somehow Mark Spencer met me and he gave me a job doing something that I wanted to do anyway, which was software development at a young age. And you know, if you know Mark, he's a very persuasive individual, and he also had this whole Asterisk thing going on too, and so I got involved through that. And so I started in about 2001, and there were about 5 of us at the company Digium. It was a lot of fun. It was a teeny tiny company, and small companies have a lot of different challenges and there's an environment though with the right kind of people that makes it a lot of fun as well. And I really enjoyed working there, and so I continued to work at Digium for that, basically that whole time. If you notice that there's a new company logo, though, there have been some changes. This last year, for those that are not familiar, Digium was acquired by Sangoma, who's one of the large competitors in the voice or the open source telecommunication space. That was kind of a big thing. It was a surprise to me. I did not realize that, that's the way things would go. But it ended up being a really, from an industry perspective, I think it'll be a good change. There's a lot of time, I think, that was spent with Digium Sangoma competing against each other for very many years, and probably wasted to some extent in that competition against each other. And now a lot of the really smart and intelligent people at both of those companies will be able to work together to try to compete upstream against bigger fish, the Mitels, the Ciscos and things like that. So I think we're excited to do that. I also had some of my job responsibilities change as well. And so that I'm not only responsible for the Asterisk project, but I'm also responsible ultimately for the FreePBX project as well. So I get to work with that project and the really talented people that are involved with it as well. So I'm going to talk a little bit about, so some of you, there are a few familiar faces here. Some of you have been either at AstriCon or been at FOSDEM or Kamile World and some of the other places I give these talks. And generally what I try to do is I try to provide, this is an opportunity for me to do some outreach to people that don't come to the US AstriCon conference, the US-based AstriCon conference, and be able to kind of give a status update with what's happening with the project, what's happened the last year or so, and where it's going, where it has been going. So a lot of this is going to be very familiar if you go to the same conferences that I go to, and I apologize for that, but hopefully there'll be a few new things as well. But so Asterisk 16 was released, which was kind of a big deal. There were 1,000 commits, 72 different contributors, and we're actually up to Asterisk 16.4 now. So there's been some time. That was Q3, Q4 last year it was released. With Asterisk, I want to talk for a few minutes about releases. And for standard releases in the Asterisk world, there's 1 year of bug fixes with major releases, followed by a year of security fixes. For long-term releases, or LTSs, there's 4 years of bug fixes, and then there's 1 additional year of security fixes. And some examples of short-term, or rather standard releases, are the 12.x branch, the 14.x branch. Some examples of of long-term releases are the 11.x branch of Asterisk and the 13.x branch. For those who weren't aware of this, Asterisk 15, we decided not to make an LTS. We broke convention and made it not an LTS. And that was due to some major enhancements we made to the core of Asterisk to change things so that it was better, it was compatible with some new things that we're trying to do with it in terms of multi-stream video and really cool browser technology, allowed you to build really cool video client experiences and things like that. And so we decided to let some of those changes bake a little bit in a standard release before we release them in a long-term release. And also, Asterisk 13 has been a really solid branch to work from. Like a lot of people, from a solidarity, from stability perspective, it's gone really well. It's been a good solid base to build telecom platform. So Asterisk 16, things turned out really well with a lot of the changes that we made in Asterisk 15. Surprisingly well, a lot better than we expected. And so we made Asterisk 16 an LTS. And so it's going to receive 4 years of bug fixes and a year of additional security fixes. So it's a good release to start looking forward to. If you're on 13.x or an older version of Asterisk, start moving forward. It's a good long-term platform to start moving to. So Asterisk 16, what's new? I'm going to talk a little bit about some of the things I discussed in retrospect about what's happened in the Asterisk 16 branch. I'm going to talk about WebRTC video quality improvements, WebRTC API additions, and some performance improvements in Ciampi JSub. Just to qualify what I'm going to talk about, I get to curate what I talk about. I get to pull from those list of 1,000 commits the things that I want to talk about, but this is by no means representative of the single direction of the project. When you're talking about 72 different people that are contributing to an open source project, you have in reality, you have 72 different individual directions, right? And so the direction I'm going to talk about is one that I think is fun to talk about, but it by no means represents the only efforts that are involved with the project. There are many other efforts as well. So Asterisk 16, we have been working on improving video resilience. And Lorenzo, this is probably familiar because we talked a little about this at Kamilo World. But video is kind of becoming a big deal, right? In terms of technologies, video is becoming more accepted in terms of user experience. If you'd asked me 5 years ago, probably 7 years ago, if I thought that I would prefer video as my default mode of communication versus just an audio-only call, I would say you're crazy. Because I thought there'd be, why on earth would you want somebody to see you on a call? Like, it's so easy, you can just talk to them and then they don't have to see you. You don't have to make sure you look presentable and things like that. But it's funny how just in the even as an adult, that just in the course of a few years, my default expectations and desires have changed, right? From a personal psychological perspective. And so video is really important. So continue to improve the video quality experience is really important for us as well. Asterisk 15, we took some brute force approaches to repairing video quality in bad network environments. They had some bandwidth implications, so they were high bandwidth reparation mechanisms. And so we wanted to start include some of the better mechanisms for doing that are in browsers. One's called a NAC message, which is essentially a way of reporting back a missing or lost packet to a sender. Say that a video packet was lost, and it allows the sender to be able to retransmit that video packet. And so we added support for that for Asterisk, and that's much less overhead than having to completely repair the stream by sending a full new video frame, if you're familiar with video compression mechanisms and things like that. Another technology that we added was called REMB. And it's a way for a receiver of, say, a video stream to be able to estimate how much bandwidth the stream is that they're receiving, how much it's taking. And you may ask why that's important. It's important because hey, I like that smile over there, Tim. So me and Tim talked a little bit about this a few months ago at Kamilo World. But it's important because, for example, if you're a sender, if you're sending a video stream and you want to send in a 1.5 meg video stream, you're having a one-to-one FaceTime call. Me and Tim are, right? And Tim, unfortunately, he is in a country where he's only able to get a very low bandwidth pipe, 64 kilobits per second, right? And I'm in a country or I'm in a place where they just installed Google Fiber, and I've got a gigabit pipe. My pipe wins, right? If I send a 1.5 meg video stream across my big fat internet connection to Tim, there's no way that packet retransmission is going to be able to repair that experience, right? Because inherently, his connection's never going to be able to transmit all the packets that I send to him. I'm sending a 1.5 meg worth of data to him, and there's an inherent physical limitation that he can only receive 64 kilobits of that. So the only way to be able to accommodate that situation, that packet loss, what looks like packet loss also, is to adjust how much video bandwidth I'm using, right? And so that's where REMB comes in, is that him as a receiver can count the packets that are received and the amount of data that's within them, and tell me that, hey, I don't know what you think you're sending, but this is what I'm actually receiving. I'm only receiving 64 kilobits of data. And then me as a sender, I can do something intelligent with that and say, oh, crud, I'm never going to win this battle, right? There's no amount of retransmission that's going to fix this situation. So I'm going to adjust my video encoder to drop the bandwidth, right? So it fits within the envelope that he's trying to, that he can support, right? So maybe a 64 kilobit, teeny tiny postage card video stream, right? I mean, it doesn't look great, but it's better than having somebody frozen or having a non-existent user experience, right? So that's what this technology allows you to be able to do. We also added support for some enhanced messaging features in Asterisk. And, so as part of our video pushes, we updated a bunch of the internal APIs in Asterisk, support multiple video and audio streams. That was in Asterisk 15. We built our really sexy, not so sexy, but workable engineering prototype that's wireframe and everything like that. It looks definitely like an engineering prototype to be able to test all the SFU technologies we built. And then we added REST APIs to be able to, build things to build these video experiences from an application perspective as well. And this is it right here, right? It's beautiful, right? Now it looks like it's built by engineers, but we do use it every day, and we're really it allows us to be. It is a good test platform for us to be able to see what we did, see how things are working, and see how they work in different environments, right? There's a problem here, though, that you don't have names, right? You see people, and you as a person know that those are people that I know. Like, I know that that's Kevin in the top left-hand corner. I know that's his Lucky Bamboo plant down at the bottom. And then I know that's Malcolm Davenport, who's a product manager over at Digium, right? But as an application developer, the guy who wrote the web page, right, you can't peek inside that video stream and attach Kevin's name to that. There's no way for you to know that. We realized that we'd forgotten something in Asterisk 15 that was important there. And so we needed to add some APIs to be able to correlate each of those video streams to like caller ID information or other metadata that's about that person, right? So you can build richer client experience. And so we can pass that information to individual participants in the conference in a that that a person may be in or an application may be in, and you can kind of build out that experience. We also added support for participant to participant messaging, so you can send messages between participants, and that includes not just text messages, but also you can set the MIME types, and you can do other types of data. You can send images or basic 64 encoded data and stuff like that. So it gives you a lot of options in terms of application development to build more fun client experiences as well. Let's talk a little bit about PJSIP. For those who aren't familiar with it, hopefully many of you know this already, because I've been trying to do a good job of repeating this and getting the message out there. But ChanSIP is Asterisk's traditional SIP channel driver. It was written, I think, in 2001, 2002. It's very old. It has served faithfully for a very long time, and it's fought a good fight. A few years ago, we decided that ChanSIP, it had organically grown to the point where it was difficult to maintain, prohibitively difficult to maintain. And for those of you that are in software development, if you find yourself in the position where when you fixed one bug, you introduced 3 other bugs, you know that you're in that environment, right? You're in an environment where you need to take a step back and figure out why you're in that situation. And we did. We kind of examined our world, and we decided that from an architectural perspective, things had kind of gotten out of hand with ChanSIP, and it was very difficult to maintain. And so we kind of decided to take all the things that we learned in the many years of doing SIP stacks and things like that and try to start over and try to do it in such a way that it was more maintainable and allowed us to build something that kind of had a more long-term future. And so we wrote the PJSIP channel driver, which is based on the PJSIP's SIP stack. And it's an external SIP stack. And we've been that's been under development for a number of years now. So if you're not on Chan PJSIP yet, it's in your best interest to kind of move forward to Chan PJSIP. So there was a talk, and this is actually not last year, it was the year before, at Asterisk about performance differences between ChanSIP and Chan PJSIP. And this is a very interesting talk to us because we want to make sure as a development group that PJSIP is always a better choice, especially in terms of performance, right? And so most cases, I think Chan PJSIP performed better, but there were a few that it did not. And so we want to make sure to address those. And it wasn't significantly better, it was just a little bit better, but we wanted to make sure that there wasn't a good reason to utilize the old SIP channel driver, particularly from a performance perspective. And so one of them that I want to talk about in particular was the inbound SIP registration performance. So a lot of people like to use Asterisk. Sometimes they use proxies, SIP proxies or whatever. Sometimes they want to do SIP registration directly with Asterisk. But there is a performance case, and if you'll notice on the y-axis, there's the percentage of CPU that's used. And on the x-axis, you'll see a bunch of different cases. This will be 200 registrations per second, 250 registrations per second, 300 registrations per second, and 350 registrations per second. And so that's kind of the data there, some different scenarios. In performance with CPU, usually lower is better. So whatever bar is lower is the winner, right? And if you look over on this side, the blue bar looks like it's the winner, right? That's actually ChanSIP. It was able to handle more registrations per second or rather is able to handle the registrations per second load at a lower CPU rate, right? And there's probably about a 5 to 6% difference between ChanSIP and Chan PJSIP in each one of these cases, right? And we did not like that, and so we wanted to make sure we went and addressed that, and so we fixed it. And so we did not fix it by sabotage. We did not make ChanSIP slower, no. But if you'll notice, now Chan PJSIP, the red bar, is lower than ChanSIP. So cool, yeah. You guys, as a development team, you went and fixed the problem, right? Yay, performance problems are fun to fix, right? So we went and addressed that. Probably one of the more fun parts about this is you notice at 350 registrations per second, there was no data. You just have data from PJSIP, but there's no data from ChanSIP. And I want to talk about that for a second. Let's see how much time I have. There was a reason for that. So we took everything we learned about good software development practices and architectures and things like that, and we threw the book at Chan PJSIP because we wanted to make it, from an architectural perspective, better across the board. Not just in the code looks cleaner and it looks pretty, but we wanted to build a better architecture. And we did. These numbers were taken on a single, I think it was like a Celeron, dual core Celeron system. So it wasn't like a special system. It wasn't like a system that was 32 cores or something like that. It was a multi-core example of a basic system, right? And it maybe had hyper-threading. I can't remember. So maybe four fake cores. I can't remember if you believe in hyper-threading. No, I say that kind of flippantly. But hyper-threading is a good technology, but it is not the same thing as 4 real cores. So if you look at this, it stops, right? There's no ChanSIP data, and there's a reason for that, and that's because ChanSIP was written a long time ago and is inherently, the protocol processing part of the channel driver is inherently single-threaded. So it is limited by a single CPU, by the maximum amount of work that a single core can do. And once we got past 300 calls per second, the scenario, like the registration scenario, would fall over due to retransmission overhead, like too many retransmissions having to occur and things like that with ChanSIP. So ChanSIP reached its limit at 300 calls per second, at least in that scenario. But as you see, Ciampi PJSIP kept going, and that's because we built it in such a way to better utilize modern CPUs, multi-core CPUs. And so the protocol processing is done across multiple CPUs. And so you can see there's an interesting story here that, you know, even though maybe there's, at least previously, right, previous to the change, there was, you know, a little bit better single core, or a little bit better performance with ChainSIP up to this point. If you wanted to scale your workload higher and higher, you were stuck. But with Ciampi PJSIP, this clearly, there's a pathway forward past 300 registrations per second right here. And so we decided that was kind of fun to talk about, even though after we fixed everything. And so we just pushed the numbers out a little bit further. And on the same system, we drove it out to 2,000 registrations per second. And we just, you know, and you'll notice it's only doing like 60 to 70, about 70% CPU in that case. So the story to be told here is PJSIP, if you want to be able to scale, you better utilize those cores that you bought. PJSIP is your horse to bet on. It will take you further. It will handle workloads better and higher. And so I would encourage you, if you haven't, move forward. All right, so let's talk about what's next in a post-16 world and some things we've been working on. Stasis and performance improvements, and I hate that we named two things. So there are things in the Asterisk, the application for getting a call into Asterisk REST interface is called Stasis. And then inside Asterisk, there's a core message bus, or like a pub sub bus, which is called Stasis as well. Those are not necessarily the same thing. So the Stasis dial plan application to drop you into the REST interface, or drop a call into the REST interface, it utilizes that message bus or whatever, but it is not necessarily the same thing. So it's a little bit confusing there. I'm talking specifically about the core itself, the message bus, because we moved a lot of things to use that, so we don't have to do a lot of funny locking things. There's also being able to do AirI, or Asterisk REST interface, without having extensions.conf. This has been a feature that's been pushed for at DevCons for a few years actually now, and we had the bandwidth to be able to do it, and so we did it this year. Actually, Dan was pushing for it. Is Dan here? I guess he's not. He's busy, but he wanted it, and so we did it this year. AirI application movement, so be able to move an AirI application, a call that's in an AirI application, from one application to another, so you can build richer application experiences. And then we added support for WebRTC Transport CC. So AirI without the dial plan, this isn't really hard. There isn't really a whole lot you have to do to take advantage of this, other than, so what happens now is when an AirI application registers with Asterisk, when the WebSocket's established, there's an automatic, internally, there's a context for that call that's called stasis dash and then whatever your AirI application's named. And so in order to take advantage of this, all you have to do is in like your pjsip.conf or your sip.conf, hopefully not your sip.conf, after everything I said, hopefully not your sip.conf, but you can set the context, the incoming context for those calls to come in to stasis dash whatever that application's name is, and you don't have to have extensions.conf anymore. It'll just drop in there, and what that does is essentially starts ARI on the application, and then after it's done with it, it doesn't hang up, right? But it's all internal, and you don't have to worry about that anymore, right? So it's kind of fun. You can have now a dial plan-less application using just ARI. We realized at this point that if you did this after some discussion on the development list, that it might be useful to be able to, within an ARI application, to be able to have the application move itself to another, have the call move itself to another application instead. Like if you don't want to build a single big monolithic ARI application that covers all your telecom cases, we added the ability to move that call from one application to another, and you just pass in this is a AirI API call, and you just pass in the channel ID, the new application name, and then the arguments over here that you want to pass to it, and then you can have the channel swap to the new application as well. This is actually fun technology that we since we got a lot of the other video stuff done that we added support for this year, and actually it's made a big difference It's called Transport CC. And actually, Lorenzo could probably talk a lot about it. I think you wrote a really good blog post, actually one or two really good blog posts about the technology. And it was, it's a sender-side bandwidth traffic estimation technology. And it's, we decided to implement an Asterisk to see if it make a difference in terms of some of the video issues we saw, and actually made a big difference. So what we saw with only a pure REMB approach for doing bandwidth estimation was that it would definitely handle the cases where sometimes you might have network transient conditions where you have temporary situations that look like long-term bandwidth problems, but they're not. They're just temporary, like, network problems. And so you'll have misestimation of the received bandwidth and things like that. So things get confused, and you'd see a scenario where maybe a long-term, after having a bunch of Wi-Fi problems or something like that, you'd have your you'd have the video show up, but it might be low quality for a long time. Like, it might be low resolution or whatever. It's like it kind of gets stuck in a low resolution mode for a long time. And once we added support for the Transport CC, that it was very quickly recovered the quality. The quality came back up very quickly, and so it provided a lot more pleasing video experience. So we're really happy with that. And I'm going to close up right here, and hopefully this will get Dan back on track as far as schedule goes. Just a reminder, Asterisk 14 went end of life, end of last year. Asterisk 15 is in security fix only mode, and it's going to be out. It's going to be probably done with that in the next few months. So if you're on either of those releases, it might be good just to get forward on Asterisk 16. Like, because Asterisk 16 is going to be around for a while. It's LTS, and it'll be a good platform to kind of get things moving forward. But I would urge you all to keep track of what's happening in non-LTS releases of Asterisk. I think there's a tendency to go from LTS to LTS, and then kind of turn a blind eye towards the standard releases. And I think that, that's probably good to do in terms of platform and things like that, but you need to periodically be checking what's going on in the standard releases as well. Generally, as project lead, I try to adhere to the principle of least surprise in terms of new features and things like that. So we try not to surprise people very much. Occasionally, things get through, and there are surprises. And so if there's a part of Asterisk that you care a lot about, it's good to go back and check and make sure that nothing significant's changed in that area. So I think that's pretty much it. Thank you guys very much for your time. Do you have any questions? Is there time for questions?
Yeah, we have time for a couple.
Okay.
Any questions?
So, Matt, I'm curious as to how the transition to Sangoma has affected the project. Has it had any effect at all, or been minor, or has it affected you in some major way? Great question, actually. So I talked a lot about tech stuff, but I didn't talk a lot about business things. But that's a really good question. So from the project perspective, Asterisk, it was kind of cool when it happened, because we were like, oh, this seems, like every time there's acquisitions and mergers and things like that, there's the way to look at it from the outside, and you're like, oh, okay, I'm looking at, but then there's also the way the employees look at it from the inside, right? And so as a project lead, I was looking at it as like, trying to figure out looking at my crystal ball and figure out what the world means after this, right? And it was actually kind of cool, because for us, I don't know if for any of you that are not aware, Sangoma is the owner or the steward of the FreePBX project as well. And so from an Asterisk team perspective, that was kind of neat, because it's like, oh, cool, we've got more relevance, right? We have another really good internal customer, right? So it seemed like, from a safety perspective and from okay, are we still relevant in the company perspective? It seemed really, like there was more increased relevance there. So that was really good. Generally it's been, we have an additional first-class customer for the project, a commercial customer, and we've got all the FreePBX customers as well, that are good people that care very much about Asterisk and things like that. So there's still a lot of relevancy in terms of the company. Did that answer your question? Yeah. Okay.
Will there be an Astrid DevCon this year?
Good question. Actually, I'm glad you asked that. It has been a really busy year, as you could tell. Yes, we are planning on doing Astro DevCon. Yeah, I just, we haven't sent out emails and things like that yet, but we are planning on doing that.
Again, one day before AstriCon?
I think so. I got to check the schedule to be sure, but I'll send out emails on the dev lists and things like that so that people can be on top of that. Yeah, great question, though.
All right, well, thank you very much.
Thanks, Kathleen.
Okay, we have a very quick break, and then we have the wonderful David Duffett up next. So be sure to come back in here.